Hi everyone, let's take another look at solving quadratics by completing the square. So we've got a few more examples, and these will be a little bit more challenging. They've just got an extra step to them, but it's nothing that we can't handle. So for numbers 1 and 2, we're finding the zeros of f of x. And remember, zeros, solutions, x-intercepts, those are all the same thing. Those terms can be used interchangeably. So if we're going to find the zeros of f of x, we're just solving for what x would be, or the x-intercepts. So in other words, when y is equal to 0, or f of x is equal to 0. So if we have x squared plus 2x minus 19, we're solving for the zeros, so we're going to set it equal to 0. And now we complete the square like we did before. So we have x squared plus 2x. We're going to move the 19 over to the other side, that constant term, we're going to add it over. We're going to fill in the boxes. And remember that that box is b over 2 squared. So here b is 2. So 2 divided by 2 squared. 2 divided by 2 is 1, and 1 squared is 1. So in each of these boxes we're going to put a 1. The left-hand side is now a perfect square trinomial, so we'll have x plus, so since we had plus 2, divide that by 2, we'll have plus 1 squared equals, and 19 plus 1 is 20. Now we're going to take the square root of both sides, so we get x plus 1 equals positive or negative square root of 20. But the square root of 20 can be simplified further, so we have to think, what are the factors of 20 where we can find one of those factors to be the largest perfect square possible that is a factor of 20? Well, if you consider 4 and 5, 4 is a perfect square, so if we would have plus or minus the square root of 4 times 5, and the square root of 4 is 2, so we'll have plus or minus 2 square roots of 5. So now we have x plus 1 equals positive or negative 2 square roots of 5. So we're going to subtract 1 from both sides, and we get x equals negative 1 plus or minus 2 square roots of 5. And both of those are the zeros for this quadratic. Now remember, these quadratics look like a parabola on the graph. They are a parabola on the graph. So there are usually, there's either 0, 1, or 2 solutions. So here we have 2 solutions. One of them is negative 1 plus 2 square roots of 5, and the other one is negative 1 minus 2 square roots of 5. So we have 2 solutions sitting right here. Okay, number 2, g of x equals 2x squared plus 4x minus 12. So first thing we want to do is set that equal to 0. And then consider, is there a greatest common factor I can take out? And sure enough, there is. In fact, not only are we considering the greatest common factor, we always want a, whatever's still sitting in front of the x squared, to just be 1. So here we're going to take out the 2, and we have x squared plus 2x minus 6 equals 0. And we're going to divide that 2 out. So both sides divided by 2, we're just left with x squared plus 2x minus 6 equals 0. Now I'm going to move that constant term over, and it's just like we've done before. So I'm going to add the 6 to both sides, fill in with the boxes. So here I've got b over 2, so here b is 2, so 2 divided by 2 squared, again that's 1. My left-hand side is a perfect square trinomial, so I'm going to factor x. Half of b over 2 is 1, and then 6 plus 1 is 7. Take the square root of both sides, so I get x plus 1 equals positive or negative square root of 7. And last step, subtract 1 from both sides, so we get x equals negative 1 plus or minus the square root of 7. Alright, so now let's look at some more down here. We've got number 3, which is 4x squared plus 2x minus 5 equals 0. So again, a here is not equal to 1. In fact, it's 4. But I don't want that. I want a to always just be 1. So that means I'm going to take out the 4 all the way to the front. So 4x squared divided by 4 is x squared. 2x divided by 4 is, instead of 2 over 4, we have 1 over 2x. So 2x divided by 4 is 1/2x. And then negative 5 divided by 4 is negative 5/4. Now I'm going to divide both sides by 4. So I'm left with x squared plus 1/2 x minus 5/4 equals 0. And even though there are fractions, it's still the same process. Move the constant term over. So I have x squared plus 1/2 x equals 5/4. Add in the boxes to both sides. So my box here, b over 2, so 1/2 divided by 2 is 1/4, so 1/4 squared is 1 over 16. So in each of these boxes I'm going to write 1 over 16. So my left-hand side is a perfect square trinomial, and I get x plus b over 2, so half of a half is a fourth, so I have x plus 1/4 squared equals, I need to get a common denominator here. So I'm going to change this 5 over 4 to a denominator of 16. So to get that, I had to multiply 4 times 4, so I need to take 5 times 4. So now I have 20 over 16 plus 1 over 16. It's 21 over 16. Take the square root of both sides. I get x plus 1/4 equals positive or negative. So if I'm taking the square root of both sides, that 21 over 16 is the same thing as the square root of 21 over the square root of 16. So I'll have the square root of 21 over 4. And then finally, I'm sorry, I ran out of room here. I'm going to subtract the 1/4 over, so I get x equals negative 1/4, negative 1 plus or minus square root of 21 all over 4. That's really messy. Let's write that again. So again, if I subtract the 1/4, I'll get x equals negative 1 plus or minus the square root of 21 all over 4. Okay. Now on to number 4. We have negative 3x squared plus 2x plus 5 equals 0. Here a is a negative number, but we can approach it the same way we did on number 3. Just factor out whatever a is if it's not equal to 1. So I have negative 3. So negative 3x squared, take out the negative 3, I'm just left with the x squared. 2x divided by negative 3 is negative 2/3 x. And then 5 divided by negative 3 is negative 5/3. Now I'm going to divide both sides by negative 3. Move the constant term over. Fill in the boxes. And the box here, okay, so we have b over 2, so if we have negative 2/3 divided by 2 squared, well, negative 2/3, half of that is, half of 2/3 is 1/3, so I'll have negative 1/3 squared. And 1 squared is 1, 3 squared is 9, so in each of my boxes I have 1 over 9. Now my left-hand side is a perfect square trinomial, so I have x minus half of 2/3 is 1/3. I need to get common denominators here, so I'm going to change this denominator to a 9. So 3 times 3 was 9, so I need to take 5 times 3. 15. So 15 over 9 plus 1 over 9 is 16 over 9. Take the square root of both sides. So I get x minus 1/3 equals positive or negative. So the square root of 16 over 9 is positive or negative 4 over 3. So my last step is to add the 1/3 to both sides so I get x by itself. So I get 1/3 plus or minus 4/3. But that's just 1 plus or minus 4 over 3. So that means that we have two solutions here. So you have positive 1 plus 4 divided by 3. So 1 plus 4 is 5 over 3, so we have 5/3. And 1 minus 4 is negative 3, divided by 3 is negative 1. And those are the two solutions. Okay, for the last two, let's switch colors so that way you can distinguish it from the other problems. How about blue? Go Bearcats. Okay, so number 5, we have 3x squared plus x minus 1. So a is 3, so I want to factor out that 3. So I have 3 times x squared plus, so 1x divided by 3 is 1/3 x, and negative 1 divided by 3 is negative 1/3. Divide both sides by 3, so we get x squared plus 1/3 x minus 1/3 equals 0. Move your constant term over. Fill in your boxes. So here the box will be, so 1/3 divided by 2 is 1/6 squared. So 1 squared is 1 and 6 squared is 36. So we're going to fill in 1 over 36 in each of the boxes. So our left-hand side is a perfect square trinomial, so we have x plus half of a third is 1/6 equals. So I need to get a denominator of 36 here. So 3 times 12 got me to 36, so I need to take 1 times 12 as well. So I have 12 over 36 plus 1 over 36 is 13 over 36. Take the square root of both sides. I get x plus 1/6 equals positive or negative. The square root of 13, we cannot simplify that anymore. But the square root of 36 is 6. So I'm going to move over the 1/6, I'm going to subtract it from both sides. And they have the same denominator, so I get x equals negative 1 plus or minus the square root of 13 all over 6. And then finally we have number 6. So we have negative 2x squared plus 5x equals 7. You could choose to subtract the 7 over and then factor out the negative 2, or think about it as whenever we're factoring out, like on number 5, when we factored out that 3, if you compare it to the next line, really it's the same thing as what we started with, we just divided everything by a. So here a is negative 2, so if I divide everything by negative 2, factoring is the same thing as dividing. So that will cancel and we're left with x squared. 5x divided by negative 2 is negative 5/2 x. And the reason I didn't want to subtract it over is because we would have to move the constant term over anyways. So now I'm going to add the box to both sides. So here I've got b over 2. So half of 5/2 is 5/4. So 5 squared is 25, 14 squared is 16. So I'm going to put 25 over 16 in each of the boxes. My left-hand side factors into x. So negative 5/2 divided by 2 is negative 5/4 squared equals, I need to get a common denominator of 16, so if I want my denominator to be 16, 2 times 8 is 16, so negative 7 times 8 is negative 56. So negative 56 over 16 plus 25 over 16 is negative 31 over 16. Now when I take my square root of both sides, I'll get x minus 5 over 4 equals positive or negative square root of negative 31 over 4. But there's just a small problem here. We have a square root of a negative number. And that just won't work because we're only looking at real numbers so far. So we'll stop there and say no real solution. Okay, well that's it. I hope that was clear. Sorry it's all crammed onto that screen, but if you were watching, you were probably able to follow along. Hope you took notes as well, because you'll probably need them in the future, and I will see you later. Bye.